These are the topics that we have covered so far. Let's go for 2.3.b, VXLAN. We are going to break down the VXLAN theory into this different session. In this session, we are going to see what is VXLAN. We are going to include VXLAN as an overlay protocol, VXLAN as a tunneling protocol, and VXLAN adoption. First of all, VXLAN stands for Virtual Extensible LAN. It is actually an overlay protocol. This means that it cannot work alone. It requires an underlay protocol running under it. So more specifically, it's a layer 2 overlay protocol that runs on top of a layer 3 underlay protocol. It is also a tunneling protocol because it is going to encapsulate Ethernet frames. So we will take an original Ethernet frame and we are going to encapsulate it with VXLAN. So we are going to add an IP header, a UDP header, and a VXLAN header. This is also known as MAC in UDP encapsulation. Let's illustrate how VXLAN works. Remember that given VXLAN is an overlay protocol, it requires an underlay infrastructure to be ready before even trying to start working. So we will need these devices and these devices to be ready. We are going to interconnect them using layer 3 interconnections. That means that we are going to use IP addresses in order to connect them to one another. And then we are going to run a traditional IP routing protocol, for instance, OSPF, EIGRP, ISIS, and so on, in order to advertise these devices loopback IP addresses and interconnection IP addresses so they can actually transport packets to one another. Once we have that infrastructure in place, now VXLAN can start working in such a way that, for instance, if we wanted to communicate this device with this other device that lives in a remote location, we could do so with VXLAN in such a way that if this device sent a frame, VXLAN will be able to transport this frame across a layer 3 network. It will be able to do so because it is going to encapsulate complete frames within IP packets. So these devices will believe that they are actually working in a traditional network. They will believe that they are in the same broadcast domain. They will believe that they are working in the same VLAN. They will be able to actually send broadcasts to the network in order to discover each other. That is how VXLAN works basically. Let's talk a bit about how VXLAN has been adopted for production networks. Originally, VXLAN started to gain track with data center solutions. It is still being adopted for data center solutions. If you go that way for a data center environment, you will be most likely using an spine and leaf topology. However, VXLAN is also gaining popularity within enterprise deployments. If you do so, you can go and use it with traditional topologies such as the 3-tier, 2-tier, and 1-tier topologies. And then you will have to make choice whether you go for the multi-vendor option. In that case, you are going to use the standard VXLAN protocol in companion of multi-protocol BGP with EVPN, which is also a standard. Or you can go for the Cisco Fabric solution. In that case, you will be using a Cisco modified version of VXLAN in companion of a Cisco modified version of Lisp. Notice that VXLAN cannot work alone because VXLAN is only aimed to move traffic through tunnels. So it is actually a data plane protocol. So it needs a control plane protocol in order to work. Let's illustrate why VXLAN is only a data plane overlay protocol and why it needs a control plane protocol. So let's say that this device here wants to send a frame to this device over here. So the frame is going to arrive to this network device. So this network device is running VXLAN. So VXLAN needs to create a tunnel in order to transport this frame within an IP packet. So the question here is, what is the destination IP address that this device needs to use in order to send this tunneled frame into this particular device here? So that is where the control plane kicks in. The control plane is going to be in charge of knowing what is the network device that these end user devices are connected to at every single moment. So the control plane is going to provide the necessary information to VXLAN in order to know that it needs to send this tunneled frame into this device. This is a summary of what we saw in this session. VXLAN stands for Virtual Extensible LAN. It is an overlay protocol because it requires an underlay protocol up and running in order to work. It is a tunneling protocol because it is going to encapsulate a complete Ethernet frame within an IP packet. We are going to add an IP header, a UDP header, and a VXLAN header. In order to deploy VXLAN in your enterprise network, you will have to make a choice whether going for the multi-vendor option where you will be running VXLAN alongside multi-protocol BGP with EVPN, or you can go for the Cisco Fabric solution where you will be running a slightly modified version of VXLAN with a slightly modified version of Lisp. We explained that VXLAN is only a data plane overlay protocol. It requires a companion protocol that is going to perform the duties of a control plane in order to actually work. That's it.